Hello and welcome everyone. In today's video, we'll learn about Solidity programming language. Now, what is Solidity? It is an object-oriented programming language and it was created explicitly for writing blockchain programs on Ethereum network. And this was constructed for designing the smart contracts on blockchain platforms. Now, when we talk about smart contracts, what is a smart contract? Now, a smart contract is nothing but a program. It's just simply a program, a line of code written on blockchain that will run on some set of conditions. And once these conditions are met, these set of conditions are automated. And in an automated way, once these conditions are met and the criteria are agreed, the contract executes. What does it mean when I say the contract executes? It's the execution of agreement so that between all the participants, whatever the Ethereums get transferred will get transferred in the form of an Ethereum. Or like we say, normally when we have an exchange of money, whenever we make any agreement, and once the agreement is signed, we then pay the amount, right? And this is what exactly happens in smart contracts, but it happens in a way predetermined way where some conditions are being set, and when those conditions are met, the contract executes and the Ethereum exchange happens against both the contracts. Now, the only benefit out of these is the execution of the agreement between all the participants can it's immediately certain, and it is without any intermediary involvement or any kind of time loss. The moment the code satisfies the condition, the agreement gets executed. So that's what a smart contract is, and that is it is nothing but a contract, but everything happening and executing automatically on a blockchain network. Now, where do you develop these contracts? Where do you write these programs? We write these programs on an IDE, like how we write a normal Java or a Python program on an IDE. Similarly, we write these programs, smart contracts, on an IDE. And that IDE that we are going to use is one of the most widely used IDE called Remix Online. Now, Remix Online is a powerful tool that is used for developing, deploying, and debugging and testing the smart contracts built on Ethereum. And these contracts, smart contracts, are only EVM compatible. That means Ethereum virtual machine, like we have Java virtual machine. Now to write these programs, we use something called as Solidity. Solidity is a compiler that we write on Remix IDE. And let's see how exactly this works. We'll understand that. But like I said, before we even start with that, you need to have some understanding on blockchain, some understanding on Ethereum, and some understanding on how a programming language works and operates. Solidity is an object-oriented language. It was written in Python, JavaScript, and C++. So when you see this session, all the videos, you will see there is a lot of familiarity you will come across if you would have worked on C++, Python, Java, or JavaScript. Sorry, not Java, but JavaScript. So it uses functions from JavaScript. It uses the class concept from C++, and it uses the concept of constructors and decorators that are used in Python. So you will see a lot of similarities between all of these languages into one single Solidity program. Now, Solidity is different from these languages. However, it is a programming language written on top of this, but it operates in a bit different way, and that's what we are going to understand in this today's video. Now, how it works? So the first thing that you need is an IDE. And as I said, we are going to use the Remix IDE. The second that it happens is once you write a program, it, it runs on Solidity compiler. Like any other language, it has a compiler. Then you write smart, then there are smart contracts which are deployed. That is the program that gets deployed, right? The deployment happens, and all this happens in Solidity. Now, when we talk about Solidity, right? Solidity as a language is again comprises of variables, functions, data types, storages, modifiers. All these stuff we'll learn in the video as we progress, as we proceed ahead. For now, you need to just have an understand that we are going to write a Solidity program using the Remix IDE, and we'll compile the program. The smart contracts will compile using the Solidity compiler, and then we'll deploy the smart contracts. That is how the flow of this course is going to be. Now, when the contracts are deployed, what does it actually mean by deploying that contract? when we say solidity compiler compiles, what does it mean, right? So let me show you one thing. If I go here, Remix IDE, the beauty is you can use it online as well as you can download and use it offline as well. I'm going to use it online. You can just go to this link .org and there you go. This is what Remix IDE looks like. Uh, if you see on the left hand side, like any other IDE, you will see certain set of options. We'll soon see how and what this means. First of all, you need to see this is workspace. You can add one more. You can create a workspace. This is how a workspace looks like. This is a default workspace. If you are working on any other project, you can create a separate workspace and you can create your Solidity files on that. Now, every Solidity file will come with .sol extension, right? And to create a file, you can click on this new file and you can write a contract over here. .sol. It comes, Solidity file comes with a .sol extension. Now, how the file looks like, let's have a quick glance over it. First of all, we'll go through in detail in each of the videos how it works. This is my first video. So let's start with and have a basic understanding of how a Solidity program looks like. So the first thing is the licensing. This is a by default, you need to have this. There's no change to this. Just add this license. Next is the versioning. The versioning happens is Pragma, Solidity, and the version. Now you can, what this indicates is that means you can use any version which is greater than or equal to 0.7, but less than 0.9. Now you can, in variety of ways you can have this. I can say, I can also just say anything greater than 0.8.0, or you can say anything that is less than 0.9.0, or you can say if you, there's also one called as, if I want to have a version 0.8.0 and anything beyond 8.0, 8.1, 8.2, but nothing that should go to a major change, like it shouldn't be major version change 0.9. So anything that is up to 0.8.n version it will allow, but if it will stop when it sees a major change in the version from 8 to 9, so it won't allow version 9. So that's how why we use this caret sign. So there are various ways of defining the version. That's what it is used for. And once you define the version, you will be able to see it over here. This is a compiler version. So see, we are using 0.8.7. So whatever, whenever you mention a version, it will only select out of these latest versions. So it will go up to 8 point. Now if I give this statement, it 0 caret 0.8.0, it will go up to this version, but it will never go up to version 9. Okay. Or if I say version, let's say 0.7.0, it will go up to up to 7.6, between 7.0 to 7.6, but it will not have a major version 0.8. So that's what this caret sign indicates. Next is we import, like any programming language, we have to import the libraries. So we'll import the console.sol over here. Then the contract starts. This is the contract identifier name that we're giving. This is nothing but a class like we create in C++. So we create a contract class as owner. In that we have certain functions, events, constructors that we will define, and we'll soon learn how this works and what everything means. Then how this, now here if you see, this is the project folder, the Explorer, Project Explorer. Then you have something called a Solidity compiler. This is what I was talking about. This is a compiler where you will compile your sol files. And then we have deploy and running the transactions. So here we'll select the environment where we are working, and then the account from which, now if you see, notice something over here, 100 ethers by default. This is not production. This is a test net. This is a test net environment. So that means it will by default provides you 100 ethers, and these are the various accounts it has. Now between each of these accounts, you can keep transferring the ethers for your testing purpose, for your code testing. Gas limit. Now gas limit, what this gas limit means? When you do certain transactions and you do some processing, there is some gas that gets consumed, and there's a limit defined to that consumption. That is what gas limit means. We'll come to that, how it works and how it is calculated. Then the value, that is the actual ether that will transfer. So if I want to transfer, let's say 2 ethers to somebody XYZ, I can select 2 ethers. Wei, Gue, Fini are the denominations under ether, right? The lowest denomination is way. So two ways is nothing but 0.0.0.0 something is what it will be. Contracts, once we create the contract, it will come over here. All the compiled contracts will appear over here. And once you deploy, it will show you the deployed contracts over here. Now let's see how it works. So I'll come back to this and I'll show you what exactly the structure looks like. Now, when you actually write a program, when you write a create a smart contract program. So let's say I'll show you over here. I'll remove this. So let's say you are writing a smart contract and the file name is sol.sol. Now every smart contract, like I said, it will have some it will be compiled on a compiler that is a solidity compiler. So we'll have a compiler over here, which is nothing but our solidity compiler. On the solidity compiler, once you compile this program, what it will do is it will split your program into two different types of files. So the first one will be ABI and the other will be bytecode. You would have heard this term many times if you are familiar with Python and Java. So it creates a compiled version of in the form of bytecode. And this bytecode is what exactly is deployed on the Ethereum, right? It doesn't deploy the whole file. It only deploys a bytecode on the Ethereum EVM for the smart contracts to execute. Now, what this ABI means, bytecode we all understand. It is a compiled code of Solidity. But what is this ABI? It's an abstract binary interface. Now, what this means and what is ABI used for? It is used for making sure that if any smart contract wants to communicate with other application smart contracts, right? And for that channel to communicate, ABI is the gateway. So ABI can be assumed as a bridge between two smart contracts to communicate. Without the contract cannot derive any data from other contract with which it wants to communicate. And for both the contracts to execute and have the conditions to the predefined conditions to meet, there you need two contracts to communicate, right? To have an agreement, two parties or the participants with two different contracts to communicate. And based on that predefined set of conditions, once they are met, these two contracts will talk to each other and they will talk through an ABI. So ABI allows one contract to communicate with an application smart contract of with another application smart contract. And when that is met, the transaction actually happens, and the transaction happens in the form of Ethereum. I'll show you by example, and you will have a better idea of what I'm trying to say. Let's say I'll take this example. Okay, now I have this code, and I'll compile this code. So once you compile this code, it's updating my compiler version to match the current. Okay, it's done. Now you see, the moment I compiled, it created two. It's split the file into two, bytecode and ABI. Now I copied this bytecode. What this bytecode means? Okay, if I go here, I'll show you bytecode to opcode. Okay, now I click here. Now I go here. What I would like to show you is I'll open a text editor app and I'll just create a new document and I'll show you over here. I'll paste this bytecode here. You see this? Now you will notice something. There are opcodes, right? These opcodes like push, miss, zero, and jump, and so on. These opcodes are nothing but instructions. These are some set of instructions to that we use for Ethereum to work, right, and to follow. Now, if you see this, this is an object key, and this is the value of the object. Now let's say I'll copy this and I'll select it from here to here. Now this is in the form of a bytecode, that is a hexadecimal value. Now if you notice there it starts on 6. Now any hexadecimal starts with what? 0x. So I'll just say 0x and then I'll paste this. And the moment I decode this, you will notice the same set of opcodes will be available over here. And these opcodes are nothing but set of instructions or commands that you send to Ethereum to do the functioning. So it's nothing but, and this is what your bytecode file exactly has. Now let's see what is if I go back over here, the ABI. So let's copy this ABI and we'll see what this ABI is. I'll copy this ABI and I'll go to my text editor again. I'll remove this and I'll copy the ABI. You see this? It is nothing but in the form of a JSON. Notice this. And this ABI, like I told you, right, it has the inputs, it has certain, instructions that we use like address, owner, where contracts names and the contract address can be defined for the transactions to take place or the exchange of Ethereums to Ethers to happen. And this is what the ABI has. So this, without this, your smart contracts cannot communicate with each other. So this is what I was trying to explain when I said that ABI is actually a channel of communication between two smart contracts. I hope I'm clear so far.